Hello everyone. So in the previous videos in this playlist, we have seen inheritance and we have seen what is method overloading. In method overloading, we have seen that there can be multiple methods with the same method name but different number of parameters or different types of parameters, different data types of parameters. Okay. So now we'll see this example where we combine all these concepts together and introduce a new concept of method overriding. Okay, so now just take a look at this class. Class animal has two methods, void make sound and void make sound string sound. Okay, so as you can see, if you have watched the previous video, you can easily tell that this is method overloading because both the methods have the same name, that is make sound, and both the methods have different number of parameters. One has no parameter, another one has one parameter. Okay, both of them have different behavior as well. So the first method, that is make sound, prints some sound, just it prints a string. Okay, whereas the second one takes the sound parameter and prints that parameter in the body. Okay, so this is method overloading. Now let's take a look at class dog. Now I'll just zoom out a bit. Okay, so now what can you see here? You can see that class dog extends animal. So by the principle of inheritance, whatever data members and member functions are present in the class animal are also inherited into the class dog because class dog extends animal. Okay. In a future video, we'll discuss about access specifiers. Just to clarify that not all the data members and member functions may be inherited into the child class. But in this case, because we have not specified any access specifier, we have not mentioned any access specifier, these are basically default access specifiers. So whatever data members and member functions have default access specifier can be inherited. Basically, only those data members and methods or member functions which are specified as private cannot be inherited by the child class. So in this case, I have written method overloading because class dog, although we have not explicitly written another method called make sound in the class dog, the two make sound methods that were already there in the class animal are also present in class dog by the virtue of the fact that class dog extends animal. Okay, so class dog now has three versions of make sound. One without any parameters, okay, one with one parameter, single parameter, and both of them are because of the animal class, and one version which is its own, that is make sound with two parameters. Okay, now in this case, what this does is it repeatedly makes some sound, and number of repetitions is also given as an argument to the make sound function. So this is about method overloading. Now, when the compiler sees different methods with different number of parameters or different data types of parameters, it can easily associate or differentiate between, basically, it can differentiate between the different versions of the methods. And when in the main method or wherever there is a function call, wherever it can be in another class or wherever, not just in the main method, but wherever there is a function call make sound, compiler itself can associate which version of the method, which version of the method is being invoked or called in this case, so that binding between the method call and the method body can be done by the compiler itself. So therefore it is called as compile time polymorphism. It is done statically because it's done before the program is actually executed. So it's also called as static binding, binding between the function call or the method call and the method body. Okay, so that is static binding or compile time polymorphism, because the compiler itself can associate the method call with the method body. That is method overloading. All three things, same name, method overloading, compile time polymorphism, or static binding. Then we have something called as method overriding. Now here you can see class dog. If you just take a look at class dog, it has void make sound with 0 parameters and void make sound with 2 parameters. Now, if you just take a look at class dog, you would think that this is overloading going on, but it's not. This is because the parent class already has a method called as make sound. So there is a concept called method overriding, which is exclusively reserved for cases where you have inheritance. So there is a parent class animal, there is a child class dog. Parent class also has the same method, that is void make sound. Now overloading and overriding are totally opposite in this aspect, that both the methods, that is void make sound from animal and void make sound from dog, both of them have the same name and same number of parameters, that is 0. Okay, and if they had some non-zero number of parameters, they should have the same number of parameters. If it is to be classified as overriding, then the number of parameters should be the same, and the sequence and data type of the parameters should also be the same. Only then we can call it as method overriding. Okay, now this is called as runtime polymorphism, because when you're when there is a call for make sound wherever in the program, if some other method or some other let's say main method or any other method calls make sound without any parameters, it is impossible for compiler to resolve or bind a particular method call to the method body, because this is a different method body, right? Here the make sound method body is bark, whereas here the make sound body is, sorry, here the make sound body is some sound. Okay, so in animal class it prints some sound, in dog class it prints bark. Okay, so the body is also different. A compiler cannot distinguish between these two. Okay, so only when you run the program, the object will get created. Some object will get created. Okay, that object may be of class animal, or that object may be of class dog. Okay, if it is an object of class animal, then the make sound method of the animal class will be executed. And if it is the object of class dog, then the make sound method of dog class will be executed. Now, to make the things even more interesting, let's say we have another class that inherits the animal class. So we have one parent, that is animal, and two child classes, that is dog and cat. And now cat also has a method called as make sound, exact same name, exact same number of parameters, that is 0, and different body, so that it prints meow. Okay, so dog barks, cat meows, whatever. Okay. So now this is called as overriding or runtime polymorphism. Now, if you observe, we have added an annotation called as @override. This is because if anyone else works on the same code and by mistake they do some change, like for example, instead of make sound with S capital, they write make sound with S small, or they forget S totally. Okay, so in that case, you get an error because of the override annotation. Okay, what is the error? Method does not override or implement a method from a super type. So immediately the developer will know that I made some change, there is some typo, and they will see the parent class and they will see that the name is actually make sound. So that is the utility of @override annotation. Okay. Now the main program where we'll call these methods is interesting. So here in the main program, there is one more important concept that we are highlighting here. If you notice, my dog and my cat, what are they? Are they objects? So if we technically see the details of these things, the right hand side, new dog, creates a dog object. Okay, so memory is allocated using the new operator. Initialization of the members is done by the constructor of the dog class. And the address of this memory location where the dog object is created is assigned somewhere. So that is the reference. Reference holds the address of an object. So animal my dog is a reference which holds the address of a dog class object. Similarly, new allocates memory for a cat object. Cat constructor will initialize the members of the cat object, and the address of the object which is thus created will be assigned to the mycat reference, which is of type animal. Now, if you notice here, normally till now, when you create objects, how do you create? Let's say dog my dog is equal to new dog, or cat my cat is equal to new cat. But here, the principle is a parent class reference, that is animal is the parent class. So parent class reference, that is my dog or my cat, it can hold the address of a child class object. Okay, so the parent class animals reference my dog can hold the address of child class object, that is dog, and parent class reference, it is animal reference my cat, can hold the address of child class object, that is cat ka object. Okay, now here if you see, I'm saying my dog dot make sound and my cat dot make sound. So the method call is exactly the same, but the output will change because the object is different. So my dog is pointing towards a dog object here, and my cat is pointing towards a cat object here. Now things become even more interesting if instead of doing it this way, what I do is if I say animal A, I'll just create a reference, or let's say animal. Okay. And here, so if I just, I'll comment this out, and here what I'll do is animal equal to new dog. Okay. And then I'll say, sorry, I'll not say this because animal is already declared. So redeclaration will give me error. Okay. And then I'll say animal dot make sound. Okay. I'll also comment this part of my code out. Okay. And now what I'll say is animal dot make sound. Okay. And now the same reference variable animal is now pointing to a cat object. And now I'm saying animal dot make sound. So now I think you can clearly see what I'm saying. I'm saying that animal, the reference is the same. At this point, it is pointing towards a dog object, and at line number 45, it is pointing towards a cat object. Depending on which object it is pointing towards, or depending on which object's address, what is the type of the object of which the address, मतलब animal reference में जो address है वो कौन से type के object का है, depending on that the particular version of make sound will be called. तो अगर animal reference में dog class के object का address है तो animal dot make sound will call the make sound from the dog class. अगर animal reference में cat object का address है तो then animal dot make sound will call the version of make sound from the cat class. Another important thing, you can do this only with overridden methods. Because make sound is overridden in dog as well as cat, you can do this. This cannot be done for methods which are exclusively present in the dog class or exclusively present in the cat class. but not there in the animal class. Okay, so animal class should have that method. Only then you can say animal dot make sound, because animal also has a make sound method. But only thing is, because right now it contains the address of dog class object, it is calling the dog version of make sound. Right now it contains the cat. Right now it contains the address of a cat object, so it calls the cat version of make sound. And if I say animal equal to new animal, okay, and now if I say animal dot makes makes sound, then it will call the animal version of make sound. Okay, so right now I'll just comment out anything else in the code, and let's just see what's the output of this much. Okay, so if I run this right now, I'll clear the previous output just to get a clear idea. So bark, because here this is because of the first make sound, where it was pointing or containing the address of a dog class object. Then meow, because it contains the address of a cat class object. And some sound, because it contains the address of an animal class object. Okay, now let's take a look at the method overloading part of this program. Now, okay, just to conclude this, an important thing over here is this is called as runtime polymorphism. Because if you just take a look at the method calls, the code itself, animal.makeSound, this line is exactly the same as at line number 43, at line number 46, and line number 49. Exactly same lines. So there is no way that the compiler can distinguish exactly which method body should I associate with the make sound method. Should I associate the dog version or the cat version or the animal version? Okay, it cannot say, because new operator is executed at runtime. So the object itself is created at runtime. Only then this address will be allocated to the reference, and only then the type will be understood. Like what is the type of the object that uh, the address of which is present in the reference. So it's completely runtime. Therefore, it is called as runtime polymorphism. Runtime polymorphism is achieved using method overriding, and as opposed to that binding happening at compile time, this binding is happening at runtime. So this is called as dynamic binding. So runtime polymorphism and dynamic binding are one and the same things. There is one more terminology used here which is called as dynamic method dispatch. This means dynamically, depending on what is the type of object that the reference points to. So the version of the method to be executed or dispatched, basically executed is said as dispatched in this case. So the version of the method to be executed or dispatched is decided dynamically at runtime. So it is called as dynamic method dispatch as well. Okay, now for the last part, let's see overloading in action. So towards the beginning of the program itself that we had seen, overloading is done purely if you just see in the animal class, where there is a make sound method with no parameters and another method with the same name make sound but with one parameter. In dog class as well, we have an example of overloading where the make sound method with no parameters is inherited and overridden. So one version is make sound same method with no parameters. Second version is make sound with one parameter inherited from the animal class. And the third version is the make sound method, again the same name, but now with two parameters. Okay. So now if we want to try this out, what we can do is okay, I'll say animal right now, animal class. Okay, right now animal contains the address of animal object. So what I'll say is, okay, what is done over here is called as typecasting. Okay, so I'll show you all the examples. Let's first go with this. So let's say animal equal to new, and let's say dog. animal equal to new dog. So now animal is pointing towards the dog object. Okay. And then here I'm casting. So this is like the type casting you do with any normal primitive data type. Similarly, you are casting a parent class reference to a child class object, or the child class type. Basically, parent class reference, that is animal, is being cast to a child class type, that is dog. Now, because dog class has three versions of make sound. If I call three versions of make sound on animal class, it will give me error because animal class only has two versions of make sound. One is the version without any parameters, and one is the version with one parameters. Okay, so even before doing this typecast, what I can do is I can say animal dot make sound and animal dot make sound, and I can pass the string, and let's say dog is whatever, singing. Let's say dog is singing or whatever. Okay, and then when I want to call the version with two parameters, then I have to use the typecasting, because animal class template does not have this version of make sound with two parameters. So I have to use typecasting, cast it to a dog type, and then I can call this method. So this is overloading in action. Okay, I'll just print a message just to distinguish it from our previous output system. Method overloading or compile time polymorphism examples. Method overloading. Okay. So as you can see the output, these three are from the overriding or dynamic method dispatch example. And from method overloading, we get bark because of the no parameter case, and it contains the address of a dog object. Then singing is because of the single parameter one, and woof is printed three times because of the two parameter one. Going further, we can also see the animal class one. Okay, so okay, if I just animal equal to, and if I say animal dot make sound and animal dot make sound, I will pass chirping or whatever. Cats also chirp, by the way. Okay, so this is chirping sound, and let's see the result of this. Okay, so some sound because of the uh, no parameter make sound method of the animal class, and this is because of the single parameter method of the animal class. So we have seen overloading with respect to the dog class and overloading with respect to the animal class as well. So that's it for this video. If you have any questions, any doubts, do post them in the comments below. Thanks for watching.